Hey guys, how are you? I miss you guys so much. So, we are stepping it up a little bit more starting this week. Okay, I want you guys to please take what I say from the heart. Okay, um, it's not okay for you guys to not be participating in this online classroom learning. You are still in school. Everything is still going to be graded. Okay, assignments are being checked. I have a whole Excel sheet, data sheet with everybody's name, all the things that I've assigned, and who did it, who did not, what's the score, all of that good stuff. And all of that's going to be entered starting next week, hopefully. Okay, so it's very important you guys all keep that in mind. Now we are going to start the quadratics unit, so I'm just doing basic introduction this week, and then we will slowly move through the unit. Okay. Please, while you guys are watching the notes video, make sure you are taking notes. Make sure you are pausing the video when you don't understand something, and make sure you rewind if you want to hear it again and again and again. That's what's nice about you having the recording of the lesson. You can always rewind, pause, rewind again. Okay. And again, remember, if you have any questions to let me know, but it's just not acceptable for anybody to making any excuses as to why they're not working. It's not acceptable to be staying up till 5 a.m. You guys should all be sleeping regular time as if it was school, 10:30, whatever it is. And I'm not saying you can't give yourself 1 or 2 days to stay up till 3 a.m., play some video games, watch some movies. I'm not saying that's not that you can't do that. Yes, you can. It's very important to have a balance. I have 1 to 2 days where I stay up till maybe 1 in the morning or 1:30 in the morning max. Okay. I don't want to be staying up later than that anyways, because I have to wake up early for my son. You guys, obviously, you don't have a kid, but you can wake up early and do other things. I'm not saying to be up at 6 in the morning, but be awake by around 9:30. That's a healthy time. So please, guys, don't take what I'm saying offensively, or don't take it, harshly. I just want you guys to have higher standards for yourself. I want you to step it up. I do not want you to keep thinking this is a vacation, because it is not. If any of you are going through a struggle, if any of you are going through a hard time emotionally, financially, mentally, there are numbers that you can reach. Just let me know that you want somebody to talk to, and I can send you the numbers. Guys, I understand it's a difficult time, but you still have responsibilities to do. And you know what? Keeping up with your academic responsibilities and your responsibilities at home will keep you healthy and happy and sane. Okay? Because your brain is doing productive things, and it's producing positive and beneficial chemicals. Okay? So go ahead, watch the notes, and if you have any questions, please write them down and ask me, okay? All right, hey guys, so let's go ahead and start with a new unit. The next unit was going to be about quadratic equations, okay? So we have already discussed, the function y equals x. Since it's to the power of 1, this is a, linear equation. And we also discussed exponential functions. So, a times b to the power of x, where it was to the power of x. So this was an exponential function. Exponential equation. Okay, and so the third and final equation type that the third and final function that we are going to discuss in Algebra 1 is called the quadratic function, okay? So this is the parent function y equals x squared, where it's to the power of 2, and so this is a quadratic. Please make sure you guys are writing this down. If you need to pause and write it down, write everything down so that when you are doing your classwork assignments, whether it's on iExcel, whether it's on Khan Academy, or whether it's in a worksheet that I upload, you have your notes in front of you to look back at, and then you're not so confused or lost. So everybody needs to be writing this down. This is not optional. This is mandatory. Write the notes down, please. Okay? So this isn't like just because you feel like it or not. Please write the notes down. If you need to pause and finish. Rewind and repeat it. Rewind. This is what's nice. It's recorded. You can rewind it as many times as you can. All right? So y equals x squared. This represents the quadratic equation. Okay, because it is to the power of 2. And this is what we are going to be spending the next, 7 weeks, 6 or 7 weeks, doing. Okay? All right, awesome. So, let's go ahead and get started, guys. So, this is the parent function, and when I say parent function, you can think of your own parents, the original function before we start stretching the graph and shifting the graph up and down and moving it left and right. This is the parent function, okay? And so a quadratic equation, the parent function's graph is at 0, 0, and it looks like a U shape, right? So the graph has a U shape. Okay, but we aren't only going to look at it in the parent function. We are actually going to be looking at it where we have the graph being, stretched, skinnier or bigger, or starting from here or here or here. Okay, so it's going to be moved. And so you will see the quadratic equation written in many different forms. Okay. Okay. So you'll see it written in different forms. We are going to talk about these as we move through the unit, so don't worry about these right now. I just want you to get a little, feel of the different equations. Just like linear, we had standard form, we had, slope-intercept form, we had point-slope form. And in quadratic, we have standard form, we have vertex form, we have factored form. Okay, so there are different forms that you are going to see the quadratic equation in, all right? But for today, we are going to look at the graph of a quadratic equation, all right? So our main focus is identifying parts of the graph. These we're gonna get to, for those who like to know ahead of time, this is a standard form. This is a vertex form. There's different names for different forms. And this is factored form. Okay. So, again, like I said, we will be getting there. Just not right now. Okay. Please make sure you're writing this down. So for today, as I said, our main focus is going to be identifying parts of a parabola. So this is where our main focus is. Okay. All right. So we're going to go ahead and get started. I already drew mine. If you want to pause the video and go ahead and take a second to draw yours. It took me about 1 minute to do this. I have a ruler, I drew this, and then I just, it was nice that these already are here. So I kind of just drew these marks here, okay? So as I said, if you take a second to go ahead and draw the graph, please draw the graph, okay? All right. So many different parts we're gonna look at, so please bear with me, okay? First things first, we have the vertex, okay? So this is the vertex, right? Your vertex is going to be your highest point or your lowest point of the graph, okay? So your vertex is going to be the highest or lowest point on the graph, okay? I will zoom in a little bit. Okay, the vertex is the highest or lowest point. And when I'm looking at here, this is my lowest point. If you see my graph, remember we always analyze our graphs from left to right. So when I'm going from left to right, as you can see, this is the lowest point. It's the vertex, okay? So I'm gonna just point an arrow to writing vertex. I'm gonna label this out. And the vertex is, I'm gonna go ahead and write the ordered pair. The vertex in this, for this parabola, it's gonna be 1, 1, 2, 3, 4, 1, -4, okay? So I'm writing the ordered pair of the vertex, which is 1, -4, okay? All right, the next thing we're looking at is the max or minimum, value, okay? And so your max or minimum value relates to the vertex, right? Because in order to find our maximum or minimum value, we have to, you know, find the highest or the lowest point on the parabola, which relates with the vertex, okay? So I know this point represents my lowest point, right? So in this case, you have to, for each graph, you have to identify, is it a maximum or is it a minimum? And in this case, this is the lowest point. Like, see where the graph is? This is my hand up. This is my hand going down, right? This is above the graph. This is below the graph. So this is the lowest point, right? So I have a minimum value, okay? And minimum value represents just the y value from the vertex, okay? And when we have max or min value, they are referring to the y value, okay? So let me use the same colors. Only y value. So for this, the minimum would be -4, right? This is x, this is y. So we want the y value, right? So if we count 0, 1, 2, 3, well, -1, -2, -3, -4, my minimum value is -4, okay? All right. The next thing we're looking at is the axis of symmetry, okay? Now, I'm not always going to be writing axis of symmetry because it is a pretty symmetry. I'm gonna make sure I'm spelling this right. It is a pretty lengthy thing to write every single time. So you're gonna see me write it as AOS for axis of symmetry. Okay? Now, if you guys don't know what the word symmetry means, symmetry is this relationship between things being exactly the same. So an axis of symmetry, look, this is an x-axis, this is a y-axis, right? So the axis of symmetry is going to represent this line, this axis that exists, right? And it's going to be a line of symmetry, a line that separates this graph into two equal parts. Now, you guys think about it. If I have this, U-shaped parabola here, where could I possibly draw a line that would cut this in half? Think about your own face. If you take your face and you want to create two separate parts, where would you draw that line? Right? Down the middle, right down the middle. All right? And that's the case with a lot of things. If you take this box here and I want to cut this into two equal parts, symmetric parts, I'm going to draw a line down the middle, right? So this is the case for many, many things. And similarly here, the axis of symmetry is the line, is the axis that goes down the middle of the graph through the vertex. It cuts through the vertex. So here's my axis of symmetry. I'm going to go ahead and grab, something like a straight edge. I just grabbed whatever was next to me. Right? And I'm going to draw that line. I know it doesn't probably look like that because of the thing I was using, but I'm going to draw my axis of symmetry down the middle. Okay? And this axis has an equation. Okay? And it's, as you can see, it's running through, it's passing through the x-axis. Right? It's passing through the x-axis. So it's going to have the equation x equals 1. All right, this is the axis of symmetry, okay? And it has the equation x equals 1. It is passing through the vertex, through the point 1. Look at, make the relationship between the vertex and the two things we just talked about after the vertex. When we wrote the vertex and then we were looking at the minimum value, we needed the y value from the vertex. When we're looking at the axis of symmetry, it's going to be the equation x equals 1, that is the x value from the vertex, okay? All right, guys, so we are 1, 2, 3, 4, about halfway through the list now after this. So the next thing we're looking at is called the zeros, or the zero. Sometimes there's only one, okay? And we will see cases of that. The zeros are exactly what it sounds like. The zeros make the equation 0, okay? So you guys have come across this many times. So they're called zeros, but they are the x-intercepts, okay? The zeros are the x-intercepts, where the parabola intersects with the x-axis, okay? So your zeros are your x-intercepts, intercept or septs. If you guys don't know what this is, why we have the s in parentheses, because it could be 1 or it could be more than 1. It's like an option. So your zeros are your x-intercepts. It's where, where does the again, make sure you're writing everything down. Graph intersects
the x-axis. Okay, and so this is my x-axis, this is my y-axis, right? I'm looking to see where my graph is intersecting with this axis here. And I see 2 points. 1, 2. I see that intersects the x-axis at 2 points. Okay, so this would be your 0. And this would be your 0. If it confuses you you're gonna be seeing these in different ways: zeros, x-intercepts, solutions, factors. You are going to be seeing this. You're gonna hear it being called and written so many different names. So pick the one that you are most comfortable with. If you like x-intercepts better, then write x-intercepts. It doesn't matter, they mean the same thing. Okay? Sometimes they just serve different purposes. Okay? So, as I said, whatever is comfortable with you guys. Remember, everybody learns differently. The words are more comfortable. So, for me, I'm just going to call them zeros. If you want to call them x-intercepts, because zeros sounds confusing, then use x-intercepts. Okay? And so this one here is that x equals -1. So, I'm just going to write them like this. Yeah, x equals -1. Or you know what? No, because x equals -1 kind of represents like an equation. So I'm going to write them as ordered pairs. So that's going to be -1, 0. And this is going to be 3, 0. Okay, so those are my 2 zeros. All right. Again, if you need to pause it so you can, or if you need to rewind it, please take advantage of those options, okay? All right. And all of these serve a purpose, and we will make the connection between this and the equation soon, inshallah, okay? All right, next we have the direction of opening. Oops, let's use a different color. Let's see, orange. Direction of opening. Okay. Direction of opening. Remember, everything is matched with its color, so don't get confused. Direction of opening is just talking about how the graph is opening. Is the graph opening upwards or is it opening downwards? This graph is opening up, okay? Notice it is going up, right? It is going up towards y, the positive infinity part of y. It is opening upwards, okay? And if it helps you, if you see this as like a mouth, right? The mouth is going up. Right? So this is opening upwards. And that allows you to identify the what type of graph we have. If we have a positive part of the equation or a negative part of the equation. It also tells you many things, okay? See, I know if a graph is opening upward, I know how it looks in my head. I know it's going to have a minimum. I know the vertex is going to be my lowest point because I can imagine a graph opening upward in my head and seeing, my vertex is always going to be the lowest point when my graph opens upward. Any type of graph that's opening upward, whether it's here or here or here or here, is going to have similar qualities in terms of the lowest point, the minimum, okay? All right, next we have the y-intercept, and that's definitely something you guys are familiar with. We don't have any more room down here, so I'm gonna, what happened to to my phone. I'm going to move it up here, okay? Y intercept. Very similar to the idea of x-intercept. You already know what y-intercept is. It's the point at which the graph is passing the y-axis. So we said the x-intercepts, where did the graph hit the x-intercept? Here we're looking, where is the graph hitting the y-axis? And it's hitting it here. See? Where my graph passes, they hit each other at this point. See, if I'm going down and I trace, this is where they intersect. Okay, so this here, my y-intercept. Okay, and that's going to be the point -1, -2, -3. So 0, -3. Okay, and we have a domain. Again, a concept you are familiar with. We have done with every single graph that we've looked at. Remember, domain represents the x values that your graph is taking on. So I'm only looking at my x-axis. This is something you kind of have to train your brain to get used to. When I'm looking at my domain, I pretend my y doesn't exist. I don't even really pay attention to it. My focus is, okay, all I see in my head is the graph and the x-axis. That's all I see. And because I see the two arrows at the ends, right? The two arrows are telling me that, okay, this graph doesn't stop here. It's gonna keep going this way. It's gonna keep going this way. We just can't show that on the piece of paper. So what that tells me is this is gonna keep going towards -infinity. And the right side is gonna keep growing towards +infinity. And so our domain is gonna be -infinity to +infinity. Okay, and it's gonna be the same domain you will see for every parabola. Okay, my range, remember, represents the y values. So again, I train my brain when it comes to my range that okay, all I see is my y-axis and my graph. I do not see the x-axis. That's just how I have trained my brain. Don't see the x-axis, see only the y-axis and the graph. The y-axis only and the graph. And when I do that, basically, I'm going to use my lowest y value, which we have, the minimum y value, which is y equals -4, right? And I need to, look at the graph and see, all right, is my graph, well, my graph is opening upward. So that means it's going up towards +infinity on the y, right? This is -infinity. If my graph was opening downward, it would be going down towards -infinity, but it is opening up towards +infinity, okay? So it would be from -4, sorry, we're gonna use brackets because that's included, to infinity. Okay, so again, if that helps you, you can write range is your min or max, comma, infinity or -infinity. Just depends if the graph is opening upward or downward. You have to look. Don't even try to come up with some type of memorization technique or whatever. Just look at the graph, guys. Just look and think. Even if it takes you 1 minute, 2 minutes, 3 minutes, look and think, okay? Starting at -4 on the y-axis, because range is y, so -1, -2, -3, -4, and it's going upward towards +infinity, all right? We're gonna move on to the next example and hopefully we can get through it a little bit quicker. And then you guys will have an assignment to do just like this, okay? All right, guys, this is the next example. I did this off camera, so I recommend you pause the video, draw the graph with the same points that I have, and write these down, and then start the video again so you're not trying to catch up with my voice. All right, after you guys copy this all down and wrote 1, 2, 3, 4, 5, 6, 7, 8, all 8 of these properties down, let's go ahead and get started now. So let's start off with the vertex. So the vertex, remember what we said, it's that point that represents, you know, it's, if you can see, like if I trace this from left to right, so from left to right, do you see the vertex, how it's that point that shows where the graph stops going up and starts going down? So at this point here, it's like the, there's a name for it, I remember, but it's like that changing point, right? So this is going up, stops and starts going down. Same thing with this first example that we did here. It was going down, 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 decreasing, stops and starts increasing. So this is like the transition point. I think that's what it is. It's the transition point. It's the point that's representing that change of like, okay, first we were going increasing, all right, stops and starts decreasing. Maybe that helps you. Okay, so this is the vertex here. And my vertex is going to be the point -2, and then let me count 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be -2, 8. Okay. My maximum or minimum value, well, first you have to identify if you do have a maximum value or if you do have a minimum value. And in this case, we have a maximum value because you need to ask yourself, is this point here, is the vertex here, is it the highest point or is it the lowest point? Okay, you have to ask yourself this question. And when I'm looking at this graph, you know, here is, you know, under the graph, here's above the graph, and if I'm, you know, above the graph, the vertex is closer to that, so this is the highest point, this is the maximum. Okay, so I'm going to write maximum, look how I did my eye. So the maximum value, and remember our maximum value is our y value from the vertex. Okay, it's our y value. So even if you don't want to look at your vertex, because, you know, really you shouldn't have that memorization technique, you should understand it more than memorize. So 1, 2, 3, 4, 5, 6, 7, 8 y. You know what, let's do so yeah, the maximum value is 8. Y equals 8. Let's just do that. All right. The axis of symmetry, remember, is that axis that cuts the graph into 2 symmetric pieces. And that cuts through the vertex. So we're just gonna go through that. So there's my axis of symmetry, and of course I'm going to label it always. Axis of symmetry, and that is running through the point x equals -2, and this represents the line x equals -2, okay? Again, if you can see, this was from the vertex, this is from the vertex, if that helps, okay? Next, we're looking at our zeros, or if you want to call them your x-intercepts, it doesn't matter. They mean the same thing. So we're looking for those points or a point. It doesn't necessarily have to be 2 points. The graph could hit it at 1 point, and I'm going to show you that. So I'm looking for where the graph is intersecting with my x-axis. Where does my graph intersect with the x-axis? And if you can see, it's doing it at 2 points, here and here. Okay, and that's going to be the point. So I'm going to label this on my 0, and I'm going to label this my 0, or if you prefer x-intercept, okay. And so that's going to be 1, 2, -1, -2, -3, -4, 0. And this is going to be 1, 2, -1, -2, -3, -4, -5. Actually, I'm sorry. So that's 0, -1, -2, -3, -4. I'm sorry, -5, -6. I don't know what I was counting. I think I was doing like, this is my y-axis. So it's 1, 2, 3, 4, 5, 6, -6. I'm not Miss Farhat if I don't make a mistake. And then this is 0, 1, 2. 2, 0. Okay. Next, we're looking at direction of opening. So is the graph opening up or is it opening down? Well, when I'm looking at this graph, it's opening down, okay? The mouth is opening downward, and if you can see the graph, the end behavior is going towards negative infinity on the y-axis. Okay, it's going down. So the direction of opening is downward. Okay. Next, we're looking at our y-intercept. Okay. Our y-intercept, remember, is the point at which the graph intersects our y-axis. So where is my graph? Here comes the C. Here, where is my graph intersecting with my y-axis? And it's doing that right here. Okay, and so the y-intercept is going to be 1, 2, 3, 4, 5, 6. So that's 0, 6. Okay. All right, so that's a 6. Okay, as you can see, where your axis and your graph end up meeting, and it's there. All right, next we have our domain, and remember that represents the x values that your function is taking on, or that can take on. Okay, so when I'm looking at my domain, I know in my head I'm like, just my x-axis, like I'm looking at that. And so I'm looking at my x-axis, I'm looking at my graph. I don't even look at my y. I don't care about anything else except this and this. And what I'm seeing is that this arrow and this arrow are indicating that the graph is going to continue going to negative infinity and continue going to positive infinity here. So my domain is going to be negative infinity to positive infinity. Okay, and my range is represents the y values. There's Hasuna. Represents the y values that your graph can take on. So when I look here, remember I gave you guys that hint where you can start from the y value from your vertex, if that helps. Whatever your min or max value is. And in this case, it's starting at 8. You see 1, 2, 3, 4, 5, 6, 7, 8. So there is nothing above here. There is no points above 8 that fall on the graph on the y-axis, okay? So it starts at 8, bracket 8. That's an ugly 8. And it is going down, since it's going downward towards negative infinity. Okay, so it's going from 8 down to negative infinity. 8 down to negative infinity. And remember, just paying attention to the y here. Okay, so before I close off with this video really quick, I wanted to show you an example of having no y-intercepts and having no x-intercepts, no zeros, or 1, 0, 1 x-intercept, okay? So just really quick, I'm not gonna go through all the details, but this is a parabola with no zeros, if you guys see what Hasuna is doing right now, he is standing on the steering wheel of his toy car and trying to reach things that he's not supposed to be playing with. But if I have a graph that, for example, looks like this, right? I have my vertex, I have my y-intercept, you know, I can tell what my domain, what my range is, what the max min value is. But notice how my graph is not passing through my x-axis. Okay? Notice how it's not passing through my x-axis. Here's my x-axis. This is not touching it. So we have no zeros, no x-intercepts here. Similarly, even if you had a downward opening graph, it would look like, you know, this. You know, where, yes, I have a vertex, I have an x-axis symmetry, I have everything, but I do not have x-intercepts. So the graph is not intersecting with the x-axis. All right. These are parabolas. By the way, I know I didn't stress it, which I would have in class, but then the name, sorry guys, hold on. The name of the shape of a graph is called parabola. So I want you to practice saying that, parabola, because you will be reading it on your directions, on your IXL, on your Khan Academy, on your homework assignments. You will be reading the word parabola. Okay, that is the graph. So parabolas with, you know, 1, 0, or x-intercept. Okay. 1, 0, 1 x-intercept. So again, parabola is referring to the name of the graph. So when they tell you draw the parabola, it's just like how you would draw the line for a linear equation. So this is called a parabola. This U shape is called a parabola. I just want to show you guys what he's doing. This is what I'm dealing with. This is what that noise is. Hasuna, what are you doing? Trying to reach things he's not allowed to. Oh my God. All right, so here is an example. He's not allowing me to think straight. Okay, so this is a parabola with 1, 0. This is how it would look. Okay, this is an example of a graph opening upward. Notice that the vertex will be the vertex will be the x-intercept. Okay, so it has only one. Okay, so see how there's only one? There's only one point where the graph is touching the x-axis. Here's the x-axis. It's only touching it one time. Okay, so then this is how it would look opening. Ooh, that flew away. So this is how it would look opening downward. Okay, so it would look something like this. Sorry, I have to play with this toy that he wants. Okay, and it would be like this. It could be here, it doesn't matter. You know, it could have been here. I'm just showing you, it could be anywhere on the graph. But see, a graph is only passing it one time. This graph is only passing it one time. Obviously, you're not gonna have two graphs on there at once. I'm just showing you, it could be here, it could be here, it could have been, you know, here, it could have been here. So this is an example of one x-intercept. It's only touching the x-axis one time. Okay, so that concludes our notes for today.